So I have a request to test these batteries which I got in the mailbag. I've been asked to test these, see what they actually like. I thought, yeah, why not? Because I've already charged them up and they seem to be okay, but why not do a discharge test and actually see if they are 1000 milliamp hours or not. I'm currently charging it up to make sure it's definitely full capacity, and it's sitting at 100 milliamp hours now, well 100 milliamps going in right now, so it was started up about 300 I think, and then it's been dropping down, so it's getting close to full charge. It's currently got a red light on here, which you can't see. Once it's fully charged, then I'm going to hook up to my DC electronic load, which is up here. I'm going to drain a 100 milliamp, and we'll see how that goes. So in theory it should take 10 hours, which I think is a reasonable time. It's not too excessive a discharge. I just want to be gentle with it and actually try and get a reasonable capacity. If I want to do it more gently, more realistic about actual usage, I'd probably do like 10 milliamp hours and do it over a few days. But yeah, I'm not going to be doing that. It's going to take too long. So I'm just going to run 100 milliamps, and we'll see how it goes at 100 milliamps. That's a 0.1 discharge rate, so 0.1C. So that's a reasonable expectation, I think. So yeah, just got to wait for this one to charge up, and then hook up to this, and we'll see how it goes. Okay, so I've started the discharge cycle. I've set up on battery, so it's using a cut-off voltage, stuff like that. So I'll try and go down to 8 volts, and then once it gets there, it'll shut off. It may not do that though, because the battery uses a boost converter. So in there is a little boost converter in here. So it's got a 3.7 volt lithium cell and a boost converter. So that boost will be fixed to 9 volts. So because of that, I'm likely to get 9 volts throughout the entire process, and it probably won't drop down until the battery actually goes flat and the discharge protection kicks in within the cell itself. That's quite likely to be what happens. I don't know, I haven't discharged one that's completely flat yet. So 100 milliamp discharge rate, and we'll see how that goes. So yeah, it'll be good to find out what capacity it's actually got. But it's definitely got 3 milliamp hours in it anyway. So as you can see, it's now been 15 minutes and it's done 24 milliamp hours so far, and the voltage has actually sagged slightly, so I'm quite surprised by that. I wasn't expecting that to happen. So it's sitting at 8.9 now, so we'll see how this goes. Maybe it will sag, maybe it will perform like a real battery, I don't know. So whilst it's discharging, I checked the cut-off voltage. It should have been 6 volts. It's a standard cut-off voltage for 9 volt batteries, both the alkaline type and lithium cells apparently. So when it actually got down to 8 volts, I stopped it, changed that value there, and well, it already stopped anyway, 8 volts. Changed the value down to 6 volts, which it should be, and we'll carry on. So it's already discharged 132 milliamp hours, and that's until the 8 volt point. So it got down to 8 volts after doing 132 milliamp hours. So anyway, we'll leave it going, see how long it goes for. Right, it says it's finished the battery test. Well, it's finished earlier than I thought it would. Let's see what we've got here. So the battery charging stopped, and I'll just restart it. I'll drop the current down to 50 milliamps instead of 100 milliamps now. So obviously dropped down to 6 volts, which is what my setting was, and that's what it had taken out, was 460 milliamp hours using 100 milliamps of draw. So now I've restarted the test using 50 milliamps, and we'll see how long it can go on for with that one. Obviously the greater the current draw, the shorter the lifetime of the battery, that you get less capacity out of the battery. So generally, if you want to do a true discharge test, you do it over a long time, something which replicates the actual typical draw you'd expect to see on the battery. So being 100 milliamps is quite a lot of draw for one of these batteries. So normally it's probably maybe 10 milliamps or something like that, or more or less 5 milliamps even. Could even be less than that. So we're talking about insignificant amounts. So because I've done a accelerated discharge, the capacity you get is going to be lower than we'd actually really get in real world. So anyway, we'll discharge 50 milliamps, and we'll see how much more capacity we get out of that. We'll let it drop off. Once it's done that, I'll drop it down to say 25 milliamps. Do it again. I'll just keep on doing that and gradually drop the current down to try and give us a maximum figure which is kind of realistic. Hopefully we'll get a bit more out of it, but say it's supposed to be 1000 milliamp hours. Yeah, well, we'll see. I mean, we're already down to 6.6. I don't think it's going to be 1000 somehow. Yeah. So, battery test is complete apparently. I ended up dropping down to 5 milliamps at the end. And this is what it actually used 490 milliamps. So that's the capacity of the battery. Probably 500 milliamps, I suppose you could say. Not 1000 milliamp hours. So, yeah, it doubled the capacity. So, yep, it's not 1000 milliamp hours. That's a lie. It's not 1000. It's 500. That's my assumption from those tests. Hope you found it interesting. Catch you later. If you're interested in these batteries, I'll probably stick a link down in the description. Yeah, otherwise they're alright.